Let's start by initializing the project with the cdktf init command, providing the template parameter and passing the Python argument to create and scaffold a new project for Python automatically. Do you want to continue with Terraform Cloud Remote Statement Management? No, we do not want that. Oh my, why is it popping up this side then? What is happening here? It swapped my no to yes. Okay, let's interrupt this run and try again. This time I'll spell no as N-O. Oh, it still insists on the cloud mode. That is unacceptable. Okay, let's interrupt again and find a way to bypass this imposition. Let's check what options the init command offers. Where is init? Here we are. Local option state. Use local state storage for generated Terraform. Okay, let's try the local switch and see what's happening. Here we go. Project name, project description, exploring cdktf with Python. Do you want to send crash reports to cdktf team? I'm selecting no, but it bet it will ignore my selection and swap it to yes. And it has. What provider do you want to use? For this project, it'll be the AWS provider. So let's come down to AWS. Press space to select and press enter to confirm the selection. Let's see what's happening next. Some files are being added here. cdktf.json is the config file. Main.py is for the application to be built. Pip file, that's the pipenv, the virtual environment for Python. cdktf provider add. You can add pre-built providers if available, or locally generated ones using the add command. This can be used to add additional providers to selected AWS. It is possible to select a version. I did not do that, so it probably will get the latest by default. cdk version is 0.17. This is the provider, the latest version, of course, and our project is in Python. Great. What is the latest AWS provider version? AWS provider, the latest version is 5.10 and was released a day ago. Let's verify with the cdktf provider list. What will it show? Here we go, 5.10 is the latest. This is the current cdktf provider AWS. What is this number? Here we go. Install package cdktf provider for AWS. This AWS provider package is managed by HashiCorp. Great. Let's see what is inside of cdktf.json file. Python, language great. Pipen will run the main.py. That's where the application will be built. Send crash reports true. I'm changing it. Changing to false. Let's see what will happen with that. Oh, interestingly, the Terraform providers list is empty. The fact that AWS has been installed does not reflect in the config file. this list is empty. CodeMaker output inputs. This is where generated AWS bindings will be rendered to. Has it been created yet though? I'm not seeing it. We'll need to add the provider to cdktf config. Add provider to cdktf.json. This is how to add a provider. I'll use AWS and expect it to pick the latest version. AWS. Let's save the changes. After the provider is added to the config file, we need to generate classes. It is done by running cdktf get command. Let's see, what does it have to get? What are these options? Disable plugin cache. Output directory for generated constructs. That is interesting. Output programming language. Okay, great. We're gonna use that. cdktf get -l-o. Downloading, and here we go. The inputs directory has been created here. This is AWS with all these models. Fantastic. Let's start with the app in the main pie. Import app, Terraform stack. This is the app to be deployed. Fantastic, and it has a single stack, my stack. It is called Project Y, and this is its scope. The scope is defined here, and we pass the app as a scope. Each construct must have a unique ID, and this is its ID. The next thing is to define AWS provider. Let's check the providers module. What have we got here? The AWS provider class in the provider submodule. So somewhere in the inputs there is an AWS provider. There it is. We need to input the AWS provider in the main. Here it is. Let's define the provider. So what do we need? Scope, the ID, and the region. So scope and the ID are probably mandatory. Okay, the access key. This is how you authenticate using one of these authentication methods. I already have set my IDE with the valid credentials. Let's see, what are the required params for this class? Scope isn't a surprise. ID doesn't surprise me either. Anything else? Not this one. Okay, what is this? Where are we? Okay, we're in the method. So path is one of the methods. We don't really need to define anything more than just scope, ID. I'm going to define the region. I have no desire to keep specifying it with every resource. So here I've got AWS provider, in use East 1 region. Let's save, and we can try to run cdktf deploy and see what's happening. Okay, it looks like the syntax is correct. No mistakes there. And we are done. It worked. Great. Let's add ecscluster to the main. So let's see what we've got in that submodule. So we've got the class in ecscluster submodule to be imported in main. Scope and IDs are of course mandatory. Are there any other required parameters? Scope, ID, the name is a required parameter. Is there anything else? Okay, these are already methods, so nothing else. Let's import this module in main then. Okay, first let's import the ecscluster class from the ecscluster submodule. So here we go, and here's the class. Next, let's define a cluster object as an instance of the ecscluster class. Here's the object, the class, scope, the ID, and the mandatory name parameter. These are the minimum required params to define ecscluster. Let's add an output for the cluster object. First need to import the terraform output construct. Let's add the output here, terraform output, give it the scope, the ID, and value to be the cluster.id. Now we can try to run the cdktf and see what's happening. cdktf diff. It's processing, the syntax is correct. Great, it worked. We've got the resource, its name and type, the on and the rest to be known after the apply, and here's the output. Defining every resource in the main file using providers classes with all their parameters will make the main file ridiculously messy and hard to read. Instead, let's create a custom construct for the ecscluster in which every element will be defined, and then import that custom construct to create the cluster object. The second change will be to replace the static hard-coded value with variables.